Hello everyone and welcome back to the Kohi Game Engine series. Today is sort of a patch video to address an issue that Greg Matthews brought up here about the alignment in the last video. There was something that I overlooked and he brings up a really good point. So he says that I don't think alignment through the dynamic allocator will work because the alignment created from free list is spoiled by the insertion of the allocator at the start of the block. If the user block is aligned, it will only be aligned if the alignment matches the size of the alloc header. And he's absolutely correct. And so what I've done is a couple of things. So first and foremost, this is actually, I've gone ahead and created a pull request with the changes. So I've already made the changes ahead of time because it was a little bit easier to just do this ahead of time and sort of explain what I did. So the first and foremost, I'm going to remove all alignment concerns from the free list. So I'm basically putting the free list back to where it was before. So the free list will no longer have to worry about that. In the K memory, I actually changed around a couple different things here just to kind of clean up this code a little bit. So instead of having this logic here to individually analyze each of the tagged allocations and write out the specific size of each of the tags and have that sort of in line, I actually moved that to a function here called getUnitForSize. So it takes the size in bytes and it outputs a floating point representation of that converted to the appropriate size metric. So if it's should be in gigabytes, it'll output 1.2 gigabytes or something like that. And so it'll set that pointer, and then it'll go ahead and return the string representation of the size increment that we're using. And so the reason that I did that was not only so I could just kind of clean this up and make this code a little bit cleaner here, but I also wanted to be able to compute the total usage of the memory because we actually weren't including that in our analytics, or our reporting rather. And so I wanted just to go ahead and add that as well. So what we've done is we've added something in here to get the total space. So the dynamic allocator total space is a new method we'll go into here in a second. That's just a simple utility method to extract the total space from the allocator. And then we go ahead and get the free space, which we already had before. We calculate the use space, then calculate the floating point, starting obviously at just a generic 1.0f. That gets overridden by what we replace it with in getUnitForSize. That gives us the used unit and the total unit and the used amount and the total amount respectively. And then we go ahead and also calculate a percentage used. So we just take the used space and divide that by the total space, casting one of them to an F64 so that we can get a fractional number. And then we just add to our output buffer here, total memory usage. And then we say the used amount with the used unit of total amount with total unit. And then it says percent used here at the end. So I feel like this is probably all the explanation that warrants, but that's the reason for those changes. So that is the core memory.c, kmemory.c rather. I also did a little bit of cleanup in our defines file to resolve a bug. I'm going to also have to address this in the math file as well, but that was a little bit outside the scope of this change, so I decided to draw the line here. Basically, I added parentheses around these macros here so that this calculation would be done first. Otherwise, if we tried to do a division before this, for example, that would happen first, and then these multiplications would happen after, and that could lead to absolutely incorrect results. So I've gone ahead and just added parentheses around those so that that value gets calculated first before it's actually used. And most of our changes, as you probably have surmised, is actually in our dynamic allocator. So actually, the only thing that we've added to dynamic allocator.h is just this total space function right here. that we see here at the bottom. So we have, all this does is reaches into the state and grabs the total size of that allocator. Okay. So the meat and potatoes of this are all in the dynamic allocator.c. So I added an assert here, so I need my asserts.h. The other thing that is done is I've changed the structure of the allocation header slightly. And so instead of holding the size is going to be held elsewhere now. We hold a pointer to the start of the allocation. I'll come back to what that means in a minute. And we also no longer store the alignment offset because we actually don't need it anymore. So because we have removed all the alignment information from the free list, we no longer actually need to store this or care about it whatsoever. So all that alloc header now holds is a pointer to the start and an alignment. Okay, so that's much smaller. And then I've gone ahead and included a macro in here for k-size storage, which is the size of a U32. That is just one for convenience in case we ever want to change this to a U64. And again, I'll explain kind of what that means here in a minute. So most of the changes are going to be in our allocate aligned and our, let's see, where's our free? Right here, our free aligned, right? So we'll go into allocation first, and then we'll hit up free. So we've basically changed out the entire meat of this function and made it work completely different. What was happening before was we were basically putting the header at the beginning, and that, of course, would throw off the alignment of the user block that comes after it. So essentially, the new memory layout that we are looking at is what we do is we first off get a required size. So that required size takes into account the alignment, so the maximum number of bytes for alignment, the size of a header, the k-size storage, which is that macro that I mentioned up here at the top, and then also the size of the allocation. Now, what is this k-size storage? So you'll recall that I removed the size from the allocation header. And the reason that I did that is because the layout has actually changed. And I'll kind of jump into that here in just a second. But we need the ability to store within this block a U32 value. And so we are making sure in our required size for our entire block of memory to include that. So that includes the alignment, the size of the header, a U32, and then the actual size of the allocation. And I did put a note in here that this cast will really only be an issue on allocations over 4 gigabytes. So basically don't do that. And I've added an assert in here to make sure that we don't have any allocations that big. Now, I don't see the reason why we would ever have an allocation that big, at least in this engine. If we ever did have an allocation that large, we could simply bump this k-size storage up to a U64 to be able to hold a size that's over 4 gigabytes, but I didn't think that was really necessary for right now. And we save a lot of storage on all of these headers by using a U32 instead of a U64. So next, after we assert that, we go ahead and we have reverted back to free list allocate block. So this allocates an unaligned block of memory from the free list. And that basically passes along the required size and returns to us a base offset, which is saved here. Our memory layout will essentially be, this is the entire block of memory that is returned from this allocate block. So at the very front, we are going to have a certain number of bytes for padding. And then we are also in the middle going to have a given number of bytes for the user memory block. So that is going to be the size that is passed in here. And basically what we're going to do is we're going to store the size of the memory block in a U32 that is 4 bytes back from the memory block itself. So that way, all we have to do is say, okay, the location of the memory block, go back 4 bytes, cast that to a U32, and bam, we have our size. The other thing that this allows us to do is it allows us to say, okay, from this point, skip over the size that was contained in here, which would be the size of this memory block, and include the allocation header at the end. So this allows us to put this allocation header at the very end of the allocated block instead of in front of it, allowing us to maintain our alignment. The other thing that we do is we go ahead and obtain the pointer from the memory block in the state itself. So we do that by, we take the base memory block out of the state itself and then add to that the base offset that we were returned up here from the free list allocate block. We go ahead and store that off as a temporary pointer, and we're just going to call that the base pointer. This is the unlined memory block, right? So it contains all of these things here, or space for all of those things, I should say. So the next thing that we do is we start the alignment after reserving enough space to hold a U32 to ensure that we have enough space for at least a U32 to exist. This allows for the U32 to be stored immediately before the user block, maintaining alignment on said user block. So what we do here is we obtain a align block offset by calling our getAlign function. And to that, we pass our pointer, which is the start of our unaligned block, plus our base offset, plus the k-size storage, and then if you recall, that's the size of U32. And then, of course, we pass along the alignment. Then we go ahead and we store the size of the block just before the user data block. So what we do is we take the align block offset, which is a U64. That's basically an address in memory casted to a U64. We subtract from that the k-size storage. So that's basically, in this case, going to be 4 bytes. And then we cast that to a U32 pointer. And so the block size is now held in that pointer. We then dereference the pointer saying set its value to size. And we cast that to a U32. Again, we wouldn't have to do that if we were using U64s, but I'm trying to save a little bit of memory here on overhead within the structure itself. So it'll be relatively simple to change. Just a couple changes within here, but again, trying to save a little bit of memory. Anyway, so then we go ahead and we store the header immediately after the user block. So we get that by saying, okay, what's the aligned block offset plus the size? And we cast that to a header, to an alloc header, right? So now that we have a pointer to that, we set the header start to pointer, which is the unallocated or unaligned block rather. So that way, when we go to free it, we know where we actually need to start from in terms of memory when we go to free it from the free list. So we store off that start pointer. We do store off the alignment. That is basically the only line in here that hasn't changed. And then, of course, we're no longer storing the alignment offset or the size this way because the size is actually stored up here. And then instead of just setting block and all of this, all we actually have to do is take the aligned block offset, which is actually just the address and memory of the start of the aligned user block. And we could just cast that to a void pointer, and that is the start of our block of memory, so we could just return that straight away. In the else clause, in other words, if this allocate block fails for some reason, we still write out a message. And instead of just setting block here, we go ahead and we return 0. We also don't return block here because that no longer exists up here. So this is a little bit cleaner, although a little bit longer. We have separated all of the alignment logic out into just the dynamic allocator and no longer have the free list worrying about that. So this makes it a little bit simpler to use, I think. Okay. So now for the free portion of this. So the free aligned, as you may recall, still just takes the allocator and a block of memory. It does not require the size. So at some point, I will actually go ahead and change the API for this dynamic allocator free to also no longer require the size. But for right now, I'm not going to worry about that too much. I'll do that, I guess, in a future pass. Because that's going to involve basically modifying potentially a lot of different places. And I really don't necessarily want to do that in the scope of this change. Anyway, so within the allocator free aligned, we basically have clobbered out the meat and potatoes of this function again and are replacing it. So instead of using our free list free block aligned, which no longer exists anymore, we are calculating some stuff and then calling free list free block. So what are we calculating? Well, the first thing we need to do is obtain the size of the block. So to do that, we go ahead and we take the block that is passed in and we subtract from that k-size storage and cast that to U32, which gives us a pointer to our block size. We can then, from that block size, figure out, based on the block plus the block size itself, where the header is and obtain a pointer to the header. We can then go ahead and get the required size based off the header's alignment, the size of the header itself, as well as k-size storage, as well as the block size that is obtained up here. We then calculate an offset by basically taking the header start position, which is always going to be a greater amount in memory than the state's memory block, and we subtract from it the memory block, and that will actually give us the offset that free list free block is looking for. So that allows us to free without actually having the size. Likewise, we have our dynamic allocator get size alignment. So this guy actually still works. We've just changed up how the information is retrieved. So we go ahead and we set the value of out size, which is just a pointer to, in this case, a U64. But we go ahead and we obtain that by, again, getting the block, which is just our user block, casting that to a U64, subtracting the k-size storage from that, cast that back to a U32 pointer, then dereference that, store the value that's stored in that pointer into out size. Next, we have a pointer here to our header, so we obtain that the same way we did above, where we take the block and then we also use the block size, which has already been set to out size, so we just obtain the value of that, get our pointer to our header, then use that header to obtain the alignment where it is set here. And finally, as I mentioned before, our dynamic allocator total space is just a utility method just to expose this state total size property rather. So that is the extent of the changes. And I'm going to go ahead and clean here and build. And I'm going to go ahead and run. All right. And if I go ahead and hit M once, we will see here that we now have our reporting looks like it's working correctly, but we also have this nice sort of synopsis down here at the bottom where we say this is how much in megabytes we've used, and that'll go up to gigabytes once we get close to gigabytes. So we've used 72.47 megabytes of 1 gigabyte total, or 0.07% roughly. Right, and so we can kind of spam this a little bit, and we can see that we have no memory leaks, which is awesome. So I'll go ahead and load up the scene here, and I will hit M again. And we see here that we still only have 72.49 megabytes, or megabytes, rather, megabytes. Can't talk, apparently. And that is because we are not actually tracking the GPU local or the Vulkan allocations yet. That is actually going to be in the next video, so we will be able to go ahead and have a look at that next time. So that's going to do it for this one. It's a relatively short one. It's a patch video, and I kind of wish I'd gotten it right the first time, but instead of taking it down and sort of redoing it, this is what happens a lot when you're working on a project like this, is you kind of get it working, and then it's like, oh, wait a minute, maybe that's not the best way to do it. And then you have to go back and adjust and sometimes change it. So while I do a lot of prep ahead of time, I don't always get it 100% right out the door. So in order to kind of keep this realistic, I try to include this stuff as much as possible. Anyway, that's going to do it for this video. Thank you guys so much for watching. If you haven't already, go ahead and toss me a like, leave me a comment if you have any questions on this. Go ahead and hit up the Discord server if you haven't already. Subscribe if you haven't already, just to make sure that you get notified as to when new videos in this or my other series drops. And I will see you guys on Friday for another video in this series. So thanks, guys. Bye.